Let us see first a numerical in the textbook, from the textbook. It is a solved example, children. It is page number 94, question number, example number 12.1. So let me write it, because I am not going to write the questions over the board. Just let me, I am going to write it the question number or example number, that is example number 12.1, children. So now let me go ahead and solve the problem this one. We need to read properly the questions, physics questions, because in the question itself the data will be present. So easily, if you know the formulas, so we need to put it in that one and we'll get the answers. So a current of 0.5 ampere is drawn by a filament of an electric bulb for 10 minutes. Find the amount of electric charge that flows through the circuit. So what he is telling in this sum means, in this question, he is telling us a current is flowing through the conductor. So let me write it, the current, how much is flowing, that is 0.5 ampere current is flowing in the conductor. So then he tells it next, for how much time it is flowing through the conductor, means the time is for 10 minutes. As I told it in my previous video, children, we need to convert first this one into a SI unit. As we all know, the time SI unit will be a second. So then in that case, 10 into, in minute, how many seconds will be there? 60 seconds will be there. So then 10 into 60 will be, it is 600 seconds. 600 seconds. Then what is trying to tell it in this, what we need to calculate it. So he is saying us to calculate the amount of charge flowing through the conductor. The amount of charge flowing through the conductor. So what amount of charge is flowing through the conductor when 0.5 ampere of current flows in a given time interval of 10 minutes. Then as I told it, the listed formulas are there in a previous video. So you just go through it. That is what, children, tell me. I is equal to Q by T. I is equal to Q by T. But the thing is, he is telling us to calculate charge. So means I need to take this time to a T to a LHS side. If I take to LHS side, then it becomes Q is equals to I times of T. I times of T. So then, what is the value of I? He mentioned it 0.5 ampere. So let me write it 0.5 ampere into time is how much? For 600 seconds. So now it will be 5 6 30, means it is 300 seconds. 300 coulomb, because SI unit of charge will be coulomb. So 5 6 30, after one decimal we need to give it 300 coulomb of charge will be flowing through the conductor when the current is flowing of a 0.5 ampere. So let me go with the next numerical. I hope it is understood, everyone. Let me repeat it one more time if you have any doubt. So even you can comment in the comment box in the current. They have mentioned it, how much it is, 0.5 ampere is flowing through the conductor, right? For how much time it is traveling. So it is traveling for 600 seconds. Then he is telling it what amount of charge has been flown through the conductor. We know that through the conductor what goes? A charge goes. So the how we can calculate that one means, then Q is equal to I into T, I times of T. Then I value I have substituted, it is 0.5 ampere, and time, that is 600 seconds. If you multiply, you are going to get 3000, but after one decimal I need to give a point, that is why 300 coulomb of charge will be flowing through the conductor in a time interval of 10 minutes, children. And let me go for the next numerical based on the amount of work done or potential difference. So let me rub this one. So as I told it, while listing out the formulas only, I mentioned it clearly. So over the work done, they will ask it numericals usually. So one numerical is there now, that is 12.2 numerical. Example number 12.2. What he is asking in that question, let us see first. He is saying how much work is done. It's very simple, children. We need to calculate the amount of work done over the charge. So they have mentioned it, charge is of 2 coulomb. Charge is of how much coulomb? 2 coulomb. So over the 2 coulomb charge work is to be done. How much amount of work is done, that we need to calculate it. Because we know that one potential difference concept. So to bring one charge from one point to another point, we need to do some kind of work. Who is going to do that work? The battery is going to do work, our cell is going to do work, source is going to do a work. So how much it is going to do a work on that 2 coulomb of charge to bring it from one position to another position? That is what we are going to do it in this case. And what is the potential difference here? V has been mentioned, it is 12 volt. Potential difference is how much? 12 volt. So in that case, let me calculate. As I told it, potential difference V equals to W upon Q. I mean work done over the charge. Work done over the charge. But he is asking how much amount of work is done. So then if I rewrite this formula, then it becomes like this, children. W equals to, I mean the amount of work done is equals to V times of Q. V times of Q. Let me substitute now V value. What is the V value, children? It is 12 volt. And what is the charge? It is of 2 coulomb. Then if you multiply it, you will get a 12 to the 24. What is the assignment of work? I hope everyone knowing this one from class 7 standard you are learning it. The assignment of work is joule. So while in a physics problem, the unit is very important, children. For a unit, if you didn't write this unit, sure, the exam, the evaluator, paper evaluator is going to deduct a half marks for the SI unit. You have to write always the SI unit. Is it clear, children? I hope the second numeric from the electricity chapter, that is example number 12.2, I hope understood it. Let me go ahead and solve the next numeric, that is example number 12.3. Example number 12.3. So the next numeric will be based on the concept called as a potential difference, or it might be a Ohm's law concept. Ohm's law concept. So over the Ohm's law concept, let me solve the numerics now. As you all know, Ohm's law, what it suggests, children? What is the statement of Ohm's law? The potential difference across, or you can say it as the current flowing through the conductor is directly proportional to the potential difference across the ends or across the terminals, provided temperature remains constant, children. So then let me go ahead and solve the numeric 12.3 or example 12.3 from the electricity chapter. How much current will an electric bulb draw from a 220 volt source if the resistance of the bulb filament is 1200 ohm? How much current will an electric heater coil draw from a 220 volt source if the resistance of the heater coil is 100 ohm, children? So here they are mentioning it using the concept called as an Ohm's law only. We need to solve this one. Clearly it is understood because they have mentioned it resistance, they have mentioned it voltage. So then anyhow we need to calculate current. So before I solve this problem, I want to convey you each and every device, children, whichever we will use it in our domestic or even our home. So every device has its own resistance. So if you consider bulb has its own resistance. So means that is why you might have been observed it over the bulb, that incandescent bulb. So they have mentioned it clearly at 220 volt. So it is going to be a this much value. They are going to tell it. Means they will be given a at 220 volt. The company who is going to manufacture what is going to assure us means he is going to assure us always at 220 volt. This is going to be a 60 power. It is going to be given to us. If power goes less or up, then he is not guaranteed. He is not going to guarantee us. So only at a 220 volt he is going to guarantee us. So let me go ahead and solve it. How much current will flow? Here two are there, children. One is electric bulb is there and one more is electric heater coil is there. So first what we will do, we will go with a electric bulb. Electric bulb. Electric bulb. How much current will an electric bulb draw? Means current how much it is going to draw, which one? Electric bulb, means question mark is current. From a 220 source, 220 source means voltage is how much, potential difference is how much, 220 volt. So then next, if the resistance of the bulb filament is 1200 ohm, resistance of the filament of the bulb, the tungsten wire which is present inside in a bulb, no, that is how much resistance it has, means 1200 ohm. Now what we need to calculate it? We have to calculate it, the amount of current drawing from the bulb. So then current equals to I equals to V by R, V by R. So let me substitute the values of V and R and let me get the answer also. So it is 220 volt voltage and resistance is 1200 ohm. Here get cancelled. So simplification is there, children. I hope you will do it, but then too it's my duty to solve it. So it is 2 11s are, right? It is 2 60s are. Now it is 11 upon 60. I hope the cancellation not goes now. So it is 11 upon 60, or you can want to tell it in a decimal, you can tell it. So very simple, we have to go with this concept. We need to divide 11 by which number? 60. So whether it goes, no, let me put a point and take 0. Now, yes, of course, 60 ones are 60. What remains here? 50 remains. As well as already we have given a decimal, so we can take it. One more. I hope it is a 6 8s are 48, then it will be 480, children. So enough for a 2 decimal, we have calculated it. So then it will be, answer will be 0.18. So is it correct, children? Anything I missed up? Yeah, of course I missed out it. What I missed out it? The unit I forgot to write it. So that is what, tell me, children? Ampere is the SI unit of current. So means the electric bulb is going to draw this much of current when the 220 voltage is supplied and the resistance of that bulb is having of 1200 ohm. Meanwhile, he is telling us to calculate the current flowing through the heater coil also, electric heater also. Let me go ahead with the heater concept. Beat one, that is electric heater. Electric heater coil. So what is the voltage? I hope voltage is same it is. So it is a 220 volt and the resistance of the heater is 100 ohm. Resistance of the heater is 100 ohm. Let me write it the data here. Current we need to calculate again and the voltage is same, it is 220 volt. As I said, it each and every device has own its resistance, that is 100 ohm it is electric heater having. So now what we need to do? We need to calculate I. I is equals to what? As I numerical V upon R. What is V value, children, here? 220 volt and R value is 100. Very simple it is. This 0 get cancelled. So then 22 upon 10, not necessary to go for division and all, just you need to remember one zero is there, I mean 2.2 ampere. 2.2 ampere. The 12.4 question is in this way, children. The potential difference between the terminal of an electric heater is 60 volt. He is directly given here. It is let me write it, 12.4th question, children, from electricity chapter, right? And here they have mentioned it. The potential difference is how much here? The potential difference is represented by letter V. So that is how much they have mentioned, means 60 volt. 60 volt. When it draws a current of 4 ampere, it is going to draw current of how much? 4 ampere current it is going to, right? Electric heater. What current will the heater draw? Oh, very interesting question, children, this one. What current will the heater draw if the potential difference is increased to 120 volt? 120 volt. First we need to understand this question. What is telling? When the potential difference is 60 volt, in that case he is telling us to a 4 ampere current will be flowing through that electric heater. Then what it suggests us means when the voltage has been increased to 120 volt, in that case you calculate the amount of current flowing through that conductor. So I'll repeat it one more time, children. He is asking us, he given it this given data, what, when the voltage is there, potential difference across the heater is 60 volt, that time the current flows is 4 ampere, right? Then he tells us if the potential difference is increased to a 120 volt, in that aspect we need to calculate a current. So just I want to tell you one thing, we don't know the electric heater resistance, because I told it in the previous numeric also, in the problem also. Each and every device has its own resistance, children. First we need to know the resistance of that device. Which device is there here? Electric heater is there. So let us calculate now electric heater resistance first based on this data. Isn't it, children? So now what do you mean by resistance? R is equal to V upon I. R is equals to, as we all know Ohm's law, V equals to what, tell me? IR. Then R is equals to what? V upon I. V upon I. So now let us substitute the value. V is how much here? 60 volt and I is 4 ampere. Then you will get confusion instead of writing assignment. So children, just a cancellation, simple calculation it is. 4 ones are 4, 4 ones are 4, 2 remains, 4 fives are 20. Then resistance of this electric heater is 15 what? 15 ohm, children. Because the SI unit of resistance is ohm, omega we will call it. The symbol for ohm is like this. Now we know the resistance of that electric heater and voltage has been increased to 120 volt. Then we need to calculate current. It's so simple now. What voltage has been increased to a 120 volt? Resistance of that electric heater remains same, 15 ohm. Now what we need to calculate? A new current flowing through that wire, we need to calculate it. So what is the formula, children? I is equals to V upon R. What is V here? 120 volt and R is 15 ohm. Sorry. So majority of the time I said it, resistance unit as amps. So no, it's a ohm, children. Then I will be 15 ones are 15, 15 eights are 120. So means 8 amps of current will be flowing when the voltage has been increased to 120 volt. And even you see it, Ohm's law, what it tells us, as you increase the potential difference, even current also increases, because directly proportional. Potential difference and current are directly proportional when the temperature is constant. You see, a potential difference is 60 volt, in that case current is 4 ampere. Now when potential difference is doubled, almost all it is 120, in that case the current is 8 amps, means current also doubled. So this is how we need to analyze the Ohm's law also with the numeric. This numeric we can realize it. Means a potential difference across the terminal is directly proportional to current flowing through that conductor provided temperature remains constant. That is what Ohm's law says. I hope this numerical also clear. Any doubt, just you can comment in the comment box, children.